This is question 66 on chemistry from the 2012 IMAT. So the question is that based on their position on the periodic table, which pair of elements is most likely to form a covalent bond? So we've got magnesium and bromine, strontium and oxygen, potassium and chlorine, calcium and chlorine, and beryllium and iodine. And we're given this simplified periodic table with the following elements. So how should we go about this? Well, at first glance of these pairs of elements, it looks like the sort of bonding that they should be engaging in is ionic. So we need to think about the difference between ionic and covalent bonding. Now, we know that these aren't just two separate things, that they're two extremes on the scale of bonding. And what do these extremes depend on? That's the difference in electronegativity between the two elements. And so what does it mean if the two atoms have very different electronegativities? Then they'd be ionic, and if they're more similar, then they'd be covalent in their bonding nature. So how are we going to do this? Well, we need to look at which pair of elements is the most similar in electronegativity, because they're most likely to form a covalent bond. So let's get started. How does electronegativity change across the periodic table? Well, we know that it increases across the period and up the group. And so what does the overall trend look like? Something like this. So the bottom left is the least electronegative and the top right is the most electronegative. So let's look at each of these pairs of elements and decide which pair is going to have the smallest difference in electronegativity. So firstly, we can see that all the first elements are metals and all the second are non-metals, either halogens or oxygen. And so we know that the non-metals are always going to be more electronegative than the metals, because this is how the trend works, because these are far on the left and the non-metals are far on the right. So we need the most electronegative metal and the least electronegative non-metal to form the most efficient covalent bond. So which pair do we think this will be? Well, firstly, we've got magnesium and bromine. Now, magnesium is fairly high up this group 2, so it's going to be somewhat more electronegative than the other metals. And bromine is further down the halogens, so maybe this isn't an implausible answer, but let's look at the rest. We've got strontium and oxygen. We can see that this is a lot more extreme. We have oxygen among the most electronegative elements, and strontium right down in the bottom left, which we know is not electronegative at all. So we can cancel this one out. Then what about potassium and chlorine? Well, similarly, potassium is quite low down, chlorine is quite high up, so this will be bad for covalent bonding. Then we've got calcium and chlorine. Well, this is the same story as potassium. Calcium's further down the group, and chlorine's very electronegative, so it's not going to be this. Then finally, what about beryllium and iodine? So beryllium is at the top of its group, iodine is at the bottom, and we said that this will be the best because beryllium is going to be the most electronegative of the metals, and iodine is going to be the least electronegative of these non-metals. And so that means they're going to have the smallest difference in electronegativity, which we know is better for covalent bonding. So our final answer is beryllium and iodine, which is E on the question paper.